Hi, welcome to day 38 of Science Challenge. Yesterday we set up an experiment where we were investigating the effect of the acidification of the oceans on some marine life that live in them. Okay, so what we did was we put some empty snail shells into two jars, one with water to act as a control to see what happens to the snail shell when it's left in water, and one into vinegar. Okay, again, both empty. We did 2 tables. If you had a balance at home that you were able to measure the mass of your snail shells before, then you're going to fill in this table and measure the mass after, work out the difference and maybe do a percentage change. If you didn't, like me, then you were going to do maybe a qualitative table where you write down your observations before and your observations after. Okay, I was going to leave this for a few days, but just looking at it, I decided I needed to do it today after just 24 hours because otherwise I'm not going to have much left. Okay, so all you're going to do is, using a pair of tweezers, remove your snail shell from your jar. So this is the one that was in pure water, or just normal tap water. If you look at the video from yesterday, you can see it already had a hole in. There is actually no change in this snail shell at all as of from yesterday. Okay, so it's still hard, it's still in one piece, and yeah, there's no change at all. If you're weighing it, dry it off, pop it on your scales, weigh it and fill in your table. Okay, now we're going to have a look at the one that's in vinegar. Okay, so I'm going to pull this out. This was a complete snail shell yesterday, but if you look at it now, there's a little bit left which is hard, but it's still actually very soft. And all of this has basically dissolved. When I put it into the vinegar, I actually noticed there are a lot of bubbles on the shell, and those are bubbles of carbon dioxide gas. These shells are made of calcium carbonate, and when that is put in acid, it reacts with the acid and forms the gas carbon dioxide. So this shell is just basically being dissolved away into the acid. So we're posed here with a bit of a problem, aren't we? Because a couple of days ago in our science challenge, we looked at the acidification of the ocean and how carbon dioxide, increased levels of carbon dioxide in the atmosphere, can dissolve into the ocean and cause the pH to lower. So with the problem of global warming and the release of carbon dioxide into the atmosphere from things like burning fossil fuels, from our cars, from factories, things like that, we're releasing carbon dioxide into the atmosphere. There's increased levels, and this is causing the oceans to become more acidic as the carbon dioxide dissolves into the ocean. As you can see, long term, this is going to have huge effects, huge ramifications for the marine life that live in these oceans. And so we need to take action, don't we? It just shows how important it is that we're reducing our carbon footprint, that we're reducing the amount of carbon dioxide that we're releasing into the atmosphere. We can all make little choices to help with that. It might just be turning off your lights when you leave a room, turning off television from standby. It might be choosing to cycle rather than drive somewhere, or getting a bus rather than getting a taxi. Because it might not be one of the obvious ramifications that you think of from global warming, but the amount and diversity of marine life that remains in our oceans, if our oceans become acidic, is going to be dramatically affected, and we're not going to have anywhere near the biodiversity that we have in the oceans at the moment. Okay, have a think about it, and I'll see you tomorrow.